Weird, isn't it? Something as seemingly trivial as the development of the ability to squish ink onto paper is regarded as being amongst, quote, the most influential events of the second millennium. Now if that's so, what does it say about today? Here, with a few clicks of a mouse, anyone can publish instantly on a global platform and at next to no cost. Here we start to find out how. In this video, setting up a Pi in text and graphics mode, interconnecting Pis and Windows, installing a web server, testing your first HTML page, and bing! First, we're going to interconnect three machines, a Windows device and two Raspberry Pis. One Pi will be in text mode and the other in graphics mode. We are then going to interconnect the three. Connect all of the network connections from each device to the gateway router, similar to the unit shown in the previous video. Add the connection to the internet. There are too many versions of Windows to support each edition, and anyway, why should we? You've paid for their operating system, let them do the supporting for you. But generally, the setup involves entering the control panel and accessing this screen to set the system to obtain an IP address automatically and obtain DNS server address automatically. If there's a wireless connection, then disable it, as this will complicate things. Save and reboot. If you've not downloaded and copied a brand new Raspbian operating system onto an SD card and installed it into your Pi before, then I suggest you do. It's a useful skill and has been covered in a previous video. As part of the setup process, you're presented with a series of questions that help to configure the Pi. This help screen can be re-invoked at any time to change the settings to suit our requirements. We need one Pi to boot into text mode and the other into graphics mode. We also need to select the settings that allow the two Pis and the Windows machine to communicate with one another. To change or confirm the settings of your existing Pi, complete the following steps. Graphics mode. On a Pi in graphics mode, click Start, Accessories, Root Terminal. A new window should open. Here you have been promoted to the most powerful user called Root. From here, if it's not already been done, you're going to set the root password and then set an account up for a friend to share your Pi. All Linux Taliban discourage this next step as it is bad practice, and they are correct, but we are going to operate as the most powerful root user. Enter. Password root, and then select and confirm a new root password. Don't forget this next time you log in as root. If you want to share your Pi with a friend, you need to create an account for them to log into. Here we will call it friend. Enter. User add friend. The account has been added. Now protect it with a password, so enter password friend. Notice the spelling. Enter a password for your friend and retype it to confirm. We will return to this account later. So back to the main task. /user/bin/raspberry-config. This runs the program at that location and should present you with a blue screen. But fear not, this is not Windows. Although it looks like another graphics window, it's a simple text menu. Use the up and down arrow keys to move between the options and press return to select your choice. First, move to SSH and press enter. This produces a second menu. Would you like the SSH server enabled or disabled? SSH is the secure login shell that allows you to control the machine remotely and is a very powerful facility. It will become your friend. More on Secure Shell later in the video. The left and right arrows allow you to select Enable or Disable. Select Enable and press Return. The screen flashes black and then returns with a blue screen SSH server enabled. Press OK to return to the original menu. Should you want to change from graphics to text or back, select the boot_behavior option. Here you can use the tab key and click Return. You're presented with a second screen. Should we boot straight into a desktop? Yes or no? A desktop is another way of saying graphical mode. Select yes or no and press enter. After a short black screen, you're returned to the Raspberry config menu. If all is done, press the tab key twice to highlight finish and press enter. If you have made changes, select yes at the next menu, which is an option to reboot. If your prompt does not tell you that you are root, then you need the power boost of being root. Enter sudo sh. Then enter password root to enter a password for the root user. Enter once and again to confirm. Remember this password and do take into account the warning of operating as root. Follow the same procedure as in the graphics mode to add a friend account. Enter user add friend. The account has been added. Now protect it with a password, so enter password friend. Enter a password for your friend and retype to confirm it. In the text mode, just enter /bin/raspberry-config at the prompt and follow the same instructions as the graphic mode to enable SSH and selecting the boot up option mode. Do note, by the way, that you only need to enter Start X in text mode to switch to graphics mode. After any reboot, you should now have all three machines interconnected, but how do we know? In the Windows machine, enter CMD in the search window. A new text window should appear. Have you started to notice our preference for text windows? Enter ipconfig and adjust the screen to see all of the output. What you're looking for is this entry here, an explanation of the three important values that have been given in the networking video. IPv4 address, the IP address of that machine. Subnet mask, the size of the local networking range. And finally, the default gateway, the address to send any traffic that is not intended for your local network. The Windows machine has negotiated these values with the local gateway router, again as explained in the previous networking video. So far so good. Now let's turn to the two Pi machines. Log in as root on both. In the graphical mode, open the root terminal window to match the window on the text machine. Enter ifconfig. Notice the slight difference in the form of the command ipconfig in Windows, ifconfig in Linux. The important details here are the values inet address and mask. The mask value should be the same on both Pis and should match the value of the default gateway on the Windows machine. Two values that should definitely not match are the inet address and this hardware address. This is known as the MAC address and was mentioned in the networking video before. It never changes and is unique to every single device on the internet. It's hard-coded into the device. Despite its importance, we will not use the MAC again until we cover advanced networking. This is the IP address. It can change at switch on time and has to be different from any other machine on the network. What will be the point of having all buildings in a street with the same house number? So these should differ. In the Pis, enter root. Here is another value that all three devices should agree on, the value of the default gateway. Recapping. We should now have three machines interconnected via the gateway router, or at least 2 out of 3 units, if that's what you want to test. The Windows machine should have been set to obtain its own networking details. You should have powerful root control in both Pis and optionally added an account for your friend with their own password into each. One Pi boots into text mode and the other into graphics. You were introduced to DHCP, Dynamic Host Control Protocol, in the previous networking video, and here it is working, hopefully. As the machines rebooted, they searched for help across the network. They found the DHCP function in the router, which allocated them an individual IP address, together with the same value for subnet mask and default gateway. These are the minimal network settings, and the values here are typical. Ping is the most basic network test. It's like a digital radar or sonar test, sending out a very short packet from your machine, which is reflected at the receiver. Another name for it is ICMP echo. Just type ping and the IP address of another machine on the network, say the gateway router, which is probably the address of the default gateway on a small setup like this. So enter ping 192.168.0.1, or the address of your default gateway. This is working correctly, and the reply received is about a millisecond, a thousandth of a second. Pinging a device that does not exist or is not connected returns this. Hold the control key down and press C to cancel any ping. All three devices should be able to ping one another and the gateway router, proving the connections. Now we can go further. One of the other functions provided by the gateway router was the naming service, DNS. Here we can perform a test on whether it works. We're often told that nuclear submarine fleets can surface in any ocean and listen for the presence of BBC Radio 4 on longwave to check that dear old Blighty still exists. Such is the reputation of the BBC and longwave propagation. So it is on the internet. Well, it is for me. I always use their site for testing. Try entering ping www.bbc.co.uk. There are two tests here. The first is on the DNS. Its job is to translate www.bbc.co.uk from the name to an IP address. This mapping is shown here and proves that the DNS is working. The second then is receiving the ping from the BBC, and here they are being returned in about 20 milliseconds. You may wonder how the Pi is connected to the BBC. Well, enter traceroute www.bbc.co.uk. This is the route to the BBC's web server. This list is the addresses and the times taken to each of the routers. These routers are housed in the nodes we saw in the diagram on the previous networking video. So we know the route could change from packet to packet based on any congestion in the network. The equivalent command for traceroute on the Windows machine is traceRT. This small diversion proves your system, how to ping another device by IP number and to check the link to the default gateway. Using ping to check the DNS is working, and then if you can ping, traceroute or traceRT will list the routers used to connect to the remote device. These are the good basic tests you can perform anywhere to check a system from a text window. You now may start to realise why we like the text window. Having proved the route, we can now go further and log into the remote machine. In this exercise, we're just going to log into the machine on the same bench, but this process is the same should you need to log into any machine anywhere in the world. The general form of the command is slogin, your username, and the IP address or name of the remote machine. In a text screen on either Pi, enter slogin friend at the IP address. On the first occasion, you will be told that the authentication of the other machine can't be established. This is part of the first S in SSH, the secure part of the connection. It occurs because the two machines have never been connected before. They do not know of one another and need to be introduced. This is a security feature. Are you sure you want to continue connecting? Enter Y. You are then warned that the other machine has been added to the list of known hosts. This is good. You won't see this challenge again unless something weird happens to the remote machine, i.e. somebody changes it, fiddles with it, or tries to imitate it in an attempt to capture your password. So beware. Anyway, enter the friend's password for the remote machine. When correct, you are now operating inside the remote machine. How simple can this be? And how powerful is this? It's stupid, but a good demonstration of how SSH works is to log back from the remote machine into your home or local machine as friend. Enter slogin friend at IP address. You can form long chains of links if you wish, consecutively logging in and out of different machines. You could soon become confused as to exactly where you are. This is why the default prompt displays your name and machine name. Type exit to close each link. To allow the Windows machine to enter your Pis, you need to download a small program called PuTTY. Installing PuTTY has been covered earlier. Just enter this address to download it and install the PuTTY program. Running it produces this screen. Enter the IP address of the machine that you want to log into this box and check that the SSH port 22 is selected. On the first occasion, enter the IP address into this box too and click Save. Double-click on the saved entry. In future, this save is not necessary. If all is well, a text screen opens and your session can begin as if you were on a Pi. Type exit to end. Review. So, to date, you know how to find the IP address of the device you are using ifconfig or ipconfig in Windows. You can discover details about your local network using root. Ping tests the connection and traceroute explains how two machines are connected. Pinging a name is a good method of testing whether the naming service is working. And finally, you can secure login from your local to remote machine. Having tested our platform, now let's do something. We'll build a web server. Your plain out-of-the-box Pi has several web browser clients installed by default, but not a web server. The client is used to view like a television set, but it's the server where the interesting stuff is. This is where the publication and hence the power lies. The server program is freely available on the net. It needs to be downloaded, unpacked and installed on your machine. Luckily, this is much easier to do than it sounds. The Pi uses one command to achieve all of this. Once again, this is where the text mode has an advantage, as it does not waste resources on a pretty, and it does have to be said, disappointingly slow graphics screen. Enter in a text screen, apt-get, install, Apache 2. The Pi toddles off and just does it. To test the server, point the client at it. This means enter the IP address into the bar like this. If it's working, you should see this. In coming videos, we'll develop this platform to learn and test a whole raft of new languages.